Hello everyone, good afternoon to all. First of all, I would like to thank the management and faculty member of IFT Engineering College, especially Dr.M.Sivakumar, Associate Professor EC Department, for giving this opportunity to me and contributing as a resource person for this AICT sponsored faculty development program. Thank you, sir. I wish you all the best for the participants. Today I am going to discuss about MATLAB applications on virtual reality and augmented reality. Let us start with our presentation. Yeah, thank you, sir. Thank you very much. Can you able to see my screen, sir? Sir, no. Okay, sir. Thank you. Thank you very much. Thank you very much, sir. First, we start with some introduction to MATLAB and the fundamentals of MATLAB and what is MATLAB and what is Simulink. Here, what is MATLAB? The name MATLAB stands for Matrix Laboratory. And also, MATLAB is a high-performance language for technical computing. Here, it integrates computation, visualization, and programming in an easy-to-use environment where problems and solutions are expressed in familiar mathematical notation. And also, there are more number of toolboxes and block set is called MATLAB. MATLAB features a family of application-specific solutions called a toolbox. Here, so many toolboxes are supported for not only with engineering stream, also scientific science and humanities, and also mathematics. Toolbox are comprehensive. What is meant by toolbox means toolbox are a comprehensive collection of MATLAB functions called M files that then extend the MATLAB environment to solve particular class of problems and areas in which toolbox are available in MATLAB. Not only with some application areas, signal processing, control system, neural network, fuzzy logic, artificial intelligence, and wireless communication, and so on. Here, another one, MATLAB introduction to MATLAB Simulink. Here the Simulink is nothing but what is meant by what is the difference between this Simulink and simulation is in MATLAB. MATLAB means textual programming by using MATLAB script editor, by using the way of typing the type like C program and other things. It's called textual programming. Where you go for MATLAB Simulink, it is a graphical representation. That is a graphical programming. Here normally it's called as Simulink is a graphical extension to MATLAB for modeling and simulation of some particular systems. It supports system level simulation, automatic code generation, and continuous test and verification of embedded system. And also the Simulink provides not only with this type of automatic code generation, continuous test, and embedded system. Here also graphical editor, some customizable block libraries, and solvers for modeling and simulating the dynamic systems. And also it is integrated with MATLAB, enabling to incorporate some more algorithms. For example, you have to include like virtual reality algorithm, some more algorithms you can incorporate into MATLAB and export the simulation result to MATLAB for further analysis. Then how to start with MATLAB in MATLAB software? How to start? How to get Simulink? Simulink is started from MATLAB command prompt. Here there is the MATLAB window. This is our MATLAB general MATLAB window. When you click for MATLAB software, you will get this type of window. Here this is a current folder window. This is your workspace window. This is your editor window. This is your command window. In this command window, just you type Simulink. Here, if you type Simulink, here one more way to get the Simulink block. Here one more icon is there for Simulink icon. Here when it starts Simulinks, it gives one single window like this. In the single window, there are options are available here. One is blank model and blank library and blank project. So many things are available here. You have to click blank model here. Then you will get the model. Take some more time to come. Next, after you get the blank model, you have to get the Simulink browser. That is a Simulink model library browser. Here, this is your model window. This is your untitled blank model window. Here, in this left, if you click on Simulink library browser, here so many toolbox. What are the toolbox present in the current version of MATLAB? Current version of MATLAB. My voice is audible, sir? Any problem with my screen? Okay, sir. Now this is your blank model of your Simulink block. In this manner, it is coming like this page. Here it takes some more time. Here there are some more options are available. In command window, just you type Simulink, you will get this type of window. You have to click this blank model here. Blank model or blank library, blank project. If you have to create one more project, means if you click blank project, it will come project based files systems also. Here now, after that you will in this window, main window, you have to click Simulink library browser. Then only you have to see the what are the toolbox present in this version of MATLAB. For example, in my system having aerospace block set, that is Arduino library, audio system toolbox, automated driving system. There are a lot of toolbox are available here. If you want additional toolbox, one more option is available to get add-on from MathWorks website. For that you have to need registration from MathWorks site, where you will get the add-ons for some particular toolbox or block set library. It available from not only with MathWorks site, also some community profiles also there. So in place of file exchange, you will get the another person's some supporting staffs creating toolbox also you can able to download here by using this. So that here if you select the Simulink, here normally it goes to some more additional blocks are available. What are the blocks inside this Simulink block? It will show in practical session. Say Okay, now we will get the blank window model. This is the icon to get the this is the library browser. It's called another word called Simulink library browser. This library browser, see parallelly. It will come. Okay, then what is the next step is building model. To create a new model, click new button here. You can go to file, click new button, and in this library browser, just you select some particular toolbox. Just to drag and drop what are the blocks you need. You just to drag and drop. Otherwise, right click on that. Click add to model means automatically it will come here. This block. Then you will be able to design what is your particular project. This is our step starting Simulink. Here for example, this is clear view. You will get starting MATLAB simulation, that is MATLAB elements are added by selecting the appropriate elements from the library browser and dragging them into model window. Alternatively, you can copy and paste. For example, in Simulink block, here sinks and sources. In sources window, just you can select the sine wave generator. In sync, you select for output devices. There are, for example, scope. Just you drag and drop in your new model. Just you then you connect with sine wave generator and scope. You will get, then click run. You will get this sine wave. If you double click on that sine wave block, you can able to change the properties of sine wave generator. For example, you can give the amplitude, frequency, and all things. By run the simulation by pressing the run button, keeping all parameters default. For this, if you want to change means you can change. Here MATLAB for everyone. Here some MATLAB online also available here. In the through this link you can get the MATLAB online. Also one more option is there, live editor. A notebook interface within MATLAB can be used to create and share your engage lectures, and that combines text and mathematical equation codes and results also you can share by using this live editor. Then access MATLAB from any web browser. Here MATLAB also supports web browsers. Here like Google Drive, MATLAB also having MATLAB Drive. Once you register with MathWorks, you can get the MATLAB Drive. Here you can save your projects and files, etc. Then MATLAB Grader also available here in this through this link. Here student assignment, use the existing problem sets or create your own, or auto grading and immediate feedback to learners. It's also available here. And instructors can contact me to request access to problem set library. Then training classes and on-ramp tutorials also available here. Here so many free lectures are available here, particularly this MATLAB Academy. Then what is introduction to virtual reality with MATLAB. Okay, now the Simulink browser is available here. Here just you here for example the common Linux blocks and aerospace blocks. Here in this particularly virtual reality toolbox, in this version it's called as previous version is called as virtual reality toolbox. In earlier versions is called Simulink 3D animation toolbox. In the 3D animation toolbox, these are all the tools are available here. If you click 3D animation toolbox, you will get this type of utilities: joystick, mouse, space mouse. This is your virtual reality to video. Here also sinks and sources available here. So if you click VR source, double click on that, add block to model, automatically post this model. Then if you want to create, here these are VR source block, double click on that. Here you have to browse your virtual reality file, that is what are the called as virtual reality 3D files, the .wrl, .x3d. One more software is available here, XFTDT. This software also called 3D used to create the antenna, any type of antenna. This is particularly for EM analysis. Here the three files are supported here. You can able to import other languages also for particularly for virtual reality 3D files. Here we are using MATLAB. The .WRL format is that is a VRML language. You can be able to get this one for VR source block. Similarly, VR source, VR syncs, and VR to video. These are all the input blocks. These are the blocks are predefined one. Here also, if you click on that, a lot of Simulink 3D animation examples also available here. Here, introduction to virtual reality toolbox. This is a three-dimensional animation of simulation results. The virtual reality toolbox in early versions of MATLAB has been renamed as Simulink 3D animation block set. And with its block set, simulation results can be displayed in three-dimensional animation. Here, what is the fundamental of virtual reality? Here, virtual reality is a term applies to computer simulation environment that can simulate physical presence in places in the real world as well as the imaginary worlds. The imaginary world can be generated by computers and can provide user interaction with audio, visuals, and sensory signals, and so that user can experience the imaginary world as if they were right inside the environment. The three-dimensional animation technique supported by MATLAB and Simulink allows the user to display simulation result with virtual reality approaches. Here, what is inside the MATLAB Simulink 3D animation toolbox. Here, by using this toolbox, visualize dynamic system behavior in a virtual reality environment, and then Simulink 3D animation links Simulink model to MATLAB algorithms to 3D graphics objects in virtual reality scenes. You can animate the virtual world by changing position, rotation, scale, and other object properties during desktop or real-time simulation. Then you can also use different types of sensors. You can use particularly in this field nowadays lidar sensor is most popular, and this type of sensor also you can using this Simulink 3D animation toolbox. Here sense collisions and other events in the virtual world and feed them back into MATLAB and Simulink algorithms. Also, you can import video from virtual cameras can be streamed to Simulink for processing. And nowadays, we are using unmanned vehicle also transmitting the video signals. Also, we can able to get the video from virtual cameras. Also, it can be streamed to Simulink for further processing. Simulink 3D animation includes editors, viewers for rendering and interactive with scenes. Here there are two more interactive tools are available here. By using this tool, you can create the new virtual world by using VRML language, and also you can able to view by using 3D animation viewer interactive app for rendering and interacting with virtual scenes. With the 3D world editor, you can import CAD and URDF file formats as well as the author details scenes assembled from 3D objects. You can import the in 3D world editor app, interactive app. You can able to import, for example, I have designed one robot in some mechanical engineering related CAD software, ANSI software. The design should be saved in the format of CAD, URDF, and other. In this format also, it can support. By using this, you can import the CAD design also. Here, this is already seen in MATLAB Simulink 3D animation toolbox library. What are this library? What are the tools and things are available here? VR syncs, VR source, VR to video, and VR text output. These are all the Simulink 3D animation toolbox component library. The one more thing, like in command window, just you type VR library, you can able to get this library directly. Whereas we are not going to Simulink, then you get a blank model, then you will get in Simulink library browser, then you will get this library. The short name, that is a short command to get the virtual reality library. Just you type in command window VR Live, you will get this type of library, Simulink library. Then another way is go to select view menu, click show library browser. Then in the MATLAB command window, click the Simulink icon. You will get the Simulink library. Then this toolbox, the 3D world can be there are two interactive apps are there. The 3D world can be viewed immersively using stereoscopic vision. You can incorporate multiple 3D scene views inside MATLAB figures and interact with the virtual world using a force feedback joystick, space mouse, or other hardware devices. These are all shown in Simulink library. Then Simulink 3D animation supports X3D format and ISO format also. It supports for representing the communicating with 3D scenes and objects. Then MATLAB provides two interactive apps for virtual reality applications. First one is 3D World Editor, another one is Simulink 3D Animation Player. Here the 3D World Editor edit virtual worlds for 3D animations. How to get the 3D World Editor? Just in command prompt you enter VR Edit and you hit enter button, you will get the VR Edit after that is 3D World Editor application. Then Simulink 3D Animation Player. Play recorded 3D animation. Where this recorder, this player is used to play the 3D animation files as recorded. At the time of simulation, you can able to record the file, record your simulation, so that you can able to play the recorded file. Here, what is the command to get this Simulink 3D animation player is VR play. Here some short introduction about 3D World Editor. The 3D World Editor app creates a virtual worlds for visualizing and verifying dynamic system behavior using Simulink 3D Animation Toolbox. Then you can able to build virtual worlds with virtual reality model language, VRML model language, or X3D, extensible 3D third parties language also, X3D language. By using this 3D World Editor, we can able to create objects in the virtual world from scratch using X3D or VRML node types. Here create objects using templates available in the 3D World Editor object library. Then import object exported from CAD tools and simplify geometries of imported objects. Then create or modify the hierarchy of object in the scene. Give objects in the virtual world unique means in order to access the form, the MATLAB and Simulink. You can also set the scene background, lighting and navigation properties and all things if possible at the time of 3D World Editor. You can set your own background, you can set lighting and navigation properties. Then define suitable viewpoints also there. Viewpoints left hand side view or top view, elevation, right elevation, left elevation, so that you can able to set your convenient viewpoints also you can set. Because of this 3D editor, you can able to design in X, Y, Z direction. You can set the viewpoints. Then this is the simple window, that is your 3D World Editor app window. Here there are 4 windows is available here in this app. What is the command to get this one? VR edit in command window. You will get 3D World Editor window. Here in this left pan, virtual scene tree with only root node. In the right pan is a empty virtual world. In the bottom pan, the empty pan for editing the objects. You can edit here itself. You can edit the objects. Then what is virtual reality modeling language? Here the extension is WRL. You can use that using this 3D World Editor. You can use virtual reality modeling language to display 3-dimensional objects in VRML viewer. Also it supports the Simulink 3D animation VRML 97 format. Then the Simulink 3D animation products uses VRM 97 technology for 3D visualization. Here it supports is an ISO standard. It is open and text based and uses a WW oriented format. You can use VRML to define a virtual world that you can display with this virtual world viewer and connect to a Simulink model. Then also this VRML, there is a virtual reality model language, provides flexible platform for creating interactive 3-dimensional scenes, and also we can able to see choose several tools, that is a VRML authoring tools. In addition, The graphics packages also there, CAD software and visual art and so on. It's also offer VRML 97 import and export features also there. Then some virtual reality world dynamic system examples. In if you get the Simulink 3D animation library browser, here itself one block is there. Here it is a link for some interface examples. For all the examples that have Simulink model, use the following procedure to run the example and view the model. Here, if you double click on that, you will get the so many examples. It directly goes to MathWorks web browser. Here itself you can open the script and we can run. Here, for example, this is a rotating membrane with MATLAB GUI. Here, this is the script file, MATLAB script file. These are already these are predefined one membrane.wrl file. In this file, you can call using the MATLAB Simulink, MATLAB textual programming. Here you can run. You will get the 3D editor. Here you can see this is your exact 3D real world editor. Here you can see this is your light option and navigation option also available here. You can set the original view along Z direction. In this manner you can set. Now let us see with this procedure. These are the so many examples are available here. Just you check it. Now start with. In the MATLAB command window, enter the name of the Simulink model. For example, you are choosing VR bounce. What will happen? We check. Then this is a command to get the bouncing ball, VR bouncing ball experiment. These are example represent the ball bouncing from a floor. Just you see this MATLAB command window. Just you type VR bounce. Take some more time, so just to meantime. By default, a virtual world also open. This 3D animation viewer or your HTML based, HTML5 based, HTML5 based, if I enable the web browser. If you close the virtual world window, double click your VR sync block to display it again. Then in Simulink window, in simulation, click run. You will get the virtual world animated view. This is your Simulink model. This model is created from this Simulink library. If you click this one Simulink library, you select Simulink 3D Animation Toolbox, where you are getting this type of blocks. This is called your VR sync. By using this VR sync, just you select the file VR bounce WRL file. You have to call the VRML language file to your MATLAB. You can able to combine two. Here this is the run button to run. Here these are the blocks available from VR signal expander, available from Simulink library browser. Then another thing, these are commonly used blocks. What are the scope is used to display output display. Then you click run. This is the way to combine virtual reality scene with you can control by using MATLAB Simulink. You can create virtual reality scenes. Just you can see when you hit the ball from floor. You can also correspondingly you can see the Y position. The VR bound examples visualize the ball bouncing from a floor. Just you can see the ball deforms here. One deform option is available here. The deform is it's the floor keeping the volume of the ball constant. The deform is achieved by modifying the scale field of the ball here. This is our ball bouncing ball example. This one. Also, you can get the graph interactively by using this plug. Okay, this is one example for virtual reality scenes. We can link to Simulink model. Then we can also add sensor to virtual world also there. Then how to add the sensor? Before you go that. Here one more thing. If you get the VRLM builder block, that is our it's also important to get this software for virtual reality apps. Here in this command window, this is a beginner user to get this install viewer and install editor. This is a command, that is a first in command with a MATLAB command window. Here you have to type vr install viewer and vr install and install editor. Then only you will get the viewer and editor option. This is a VRLM Builder 2.0 software provided with MATLAB. Is a practical visual tool to create and edit VRML models. It allows the user to create scenes essential for imaginary worlds or virtual reality. This VRLM, that is WRL program, is provided with 3D animation block set and can be installed automatically in the folder VRLM program. For the modeling facilities, VRLM software to fully used certain installation tasks must be set in the MATLAB command window with the command, this particular type of command. Then you will get this type of window. If you type VR edit in command window, already you see here, just you type VR edit in command window, you will get like this type of 3D world editor window. Here already you saw there are bottom pan and left top pan is available here. This is your command window. Here how to add sensors and how to add some more objects. Here this is your virtual reality scene. Here you can select add node option, or also always click in a new file, or you can able to new template or open another WRL file, that is your VRML file. You can able to import here. Otherwise you just click root. Here click add, that is your appearance is what is your color you want. You can choose the appearance color. Here texture, transform and all things. Material, what material you have to include here. For example, how it creates a, for example, this VR bounce example, you can import from insert from component library. Here there are a lot of components are available here. Here for example, aircraft applications. Here you can see in the aircraft, different types of aircrafts is available here. You can here click OK means you will get the aircraft in three-dimensional object. Here for example I am choosing this this air, not only with this one aircraft. Here animals and apparels, architecture, backgrounds also you can choose. This type of background you can choose. Not a material field, is a transform. In this way you can add your nodes here. Insert from material library means you can get, just if you want to Get the material means you have to click in the root folder, click material, then only you will get. There is a material cyan block and yellow plastic. It takes some more time to load. Textures. Here you can select, for example, aircraft. Here itself you can able to rotate in this way. For example, in you can see the XYZ direction, 3D direction. You can able to change. Here one more option to get the material library and texture library. In material library, you can choose this is a transform option operation. In this manner you can generate your own design by using this 3D world editor. In this way, for first you click what is the procedure, step by step procedure is given in PPT. With the file, click new file menu in VRM builders interface. A new editing will open like this. Then click plus sign to the left background object, and the project background will be displayed. Then it can be seen that there are 4 options in the ground floor property, then allowing user to specify the color and all things. Here these are all the libraries, how to import library, how to import the objects and materials. These are by using this VRLM builder 2.0. You can also import many objects like cylinders, cuboids, cones can be added to well edited window. Then this is the add sensor window. In this, to interact with simulation of model based on user actions or events occurring in the virtual world, you can use virtual reality sensors. Using the sensor, you can define a sensor node which generates events and outputs value depending on the time navigation and actions and the distance changes in the screen. Here, for example, touch sensor is used to track the location and state of the pointing device. The sensor detects when you point at the geometry containing the touch sensor node parent group, and add a VR source block and select the sensor properties to read. If you want to say, track the sensor characteristic, you have to add the VR source block. These are the simple code to read the sensor values from MATLAB. In this command window, just you type, these are the 5 steps are there, how you can read the sensor output value into the MATLAB variable set point. Particularly here, there is a magnetic elevation program is there here in this here. But the virtual scene for magnetic elevation model, it is a file name already stored in example model. Just it contains a plane sensor. The plane sensor is attached to the ball geometry to register your attempts to move the ball up and down when grabbing it with your mouse. Just you can type this. Just you can type all things in command window. You will get step by step. Finally, you will get the sensor readings here. First, what are the steps is, first create the real world object using the open world algorithm. Open world. Here, this is the command used to call the magnetic elevation model example. Open command. Then get the node handle. Previous one is you can able to add the nodes and appearance, add the texture, add the materials in the manual manner. This is where programmatic point of view you can add. Get the node handle, then synchronize the translation field, then read the synchronized field value using one of these 3 alternatives. Then you can be able to rotate or translate the sensor behaviors. Here, this is the command to use to view the sensor values. After hitting the run button, you will get this answer: sensor readings value. Here another way, for previous one is you have to get the VR world using VR edit command. Then after hitting the VR edit command in command window, you will get this VR editor block where you have to choose new design and add nodes like materials. What are the materials? What are the textures? What are the objects you can add, and set the viewpoint also. Here another example is by using MATLAB main window or command window. You can type this type of instructions, this type of commands. You will get the sensor readings. You can able to create some more virtual reality programs also there by using this MATLAB script format. Here these are already start with the VR bounce example. This is a virtual reality world and dynamic system examples. This VR bounce example represent a ball bouncing from a floor. Here the deformation is achieved by using this one. Then next one, you start with vehicle dynamics visualization with the graphs. Here also VR bounce also, when ball hit the floor, we can see the flow of bouncing ball in scope also there by using this MATLAB, also with this virtual world editor window. Just you can combine virtual window, virtual editor, and also you can call the VRML function file by using this VR sync application in Simulink MATLAB Simulink window. Here another example we are going to see vehicle dynamics with visualization with graphs. Here these examples. Here first we start with this virtual reality. We are active VR example. Participants, any doubt regarding this one? Please unmute yourself. Anybody? Participants, can you hear my voice? Okay, sir. Sir, any doubt participants can ask, because this time I am going fast, I think. Okay, sir. Anyway, these are combination performance of this one for virtual editor versus your MATLAB Simulink. It is a example already available in MATLAB. This is a vehicle dynamics visualization. Here, only the two blocks are using here. VR visualization blocks like VR sync and VR source block. These are VR visualization blocks. Here, this is a virtual scene created by using this virtual 3D virtual editor block. Here you can import, we can design the already design this one pre-designed one. Just you can call the file. Here the user can set the car viewpoint from right and above head. Then next one driver view, inside view, and then above head view. Then view from above. Then car mirror window. This is your car mirror camera view. In this way, you can set the more number of set point view set point. You can set here. You can choose walk or examine or fly or none. You can choose here. Here in this window, file viewpoints. You set the viewpoints, navigation point, rendering points. These are simulation start and stop button. Here recording also there. In this frame, not in this particular example, not optional for start recording and stop recording. Only you can be able to capture the screen only. Then next is example you are going to use with this recording option also there. Just you click run button. After run, it shows car moving. Here itself you can see lot of viewpoints are available here. In this manner, you can create virtual reality games also by using this one. After that, you can export in the form of AVI file here. If in this example not having recording option, then next example we are going to see with the recording option. With some more options, some more commands you are using with MATLAB. You can control what is the application of this virtual and augmented reality application, particularly using MATLAB means you can control here not only with in my virtual reality scenes. Here you can control the car movement, and you can also you can combine with you have to get the graph and all things. You can able to analyze all things by using this MATLAB Simulink. Here this is a one more example. Then another example is a with the graph. It is a visual weak dynamics visualization with graph options. Now you will get and the previous example is example shows only the benefit of visualization of computer dynamic model in the virtual reality environment. Here this example extends the VR Activa. This previous example shows VR Activia example. Here it starts with one more graph also you can able to get. And this example is an extension of the previous example VR Activia example, and shows how to combine this virtual reality canvas in one figure. This one figure with other graphical user interface objects like speed, longitudinal acceleration, and lateral acceleration. You can able to capture. In this case, there are three graphs are there. It displayed under the virtual scene and updated in each and every major simulation time step. Here these are here some more option is available here with light and without light, and this one you can also set the viewpoints. Okay. Here also you can see the movements here. There you can save the file format and the frame capture. Next example, I'm showing the recording option with recording option. Here in this manner, in vehicle dynamics, the VR visualization with the graph subsystems. Here subsystem is there. VR visualization subsystem. It's called as subsystem. This VR visualization with graph subsystem contains this VR Activa VRML program. Here in this VRML program, calling with MATLAB VR visualization subsystem. By using that, you can able to set the S function that provide this functionality of this virtual reality animation. Okay, these are VR graph examples. The virtual world displays three graphs and that update each and every major simulation time steps. The next one, the VR collisions. Then collision detection using line sensor. There is a command how to get the. This is the command to get the example in my MATLAB command window. Just you type VR collisions. Here this is a collision detector line sensor. Here these are VR source and this is your VR sync. Here we click library browser, Simulink library browser. Go to Simulink 3D animation toolbox. Inside this toolbox, you will get the blocks are available here. By using this, just you drag and drag, you can create your own model. This is an example collision detector line sensor. Here in the 3D world editor, you can by using this node option. There is a previous one VRLM software. Here you create your own design. This is where viewer, animation viewer, this one. Here you can simulate by using not only with Simulink. Here also you can able to simulate your design. After hitting design, the line sensor detects if there is any obstacle, detects the line sensor with light. So it glows the light. Take some more time to. Can rotate, can view direction. You can see now the robot is moved. You see if it is obstacle detected, the light is glow. In this manner, we can design one collision detection using line sensor. Here one more thing is by using this MATLAB application, one more advantage. If you create one design with MATLAB Simulink, also you can able to generate code also. See, if you have to implement in any other hardware, we can able to generate HDL program and all things we can able to generate here. You can also set the hardware also. For example, we are using Arduino hardware. You can choose the hardware. Click the model parameter block. Here you can choose the hardware. What type of hardware you are going to implement. For example, I want to use Arduino hardware. Here you can choose. Take some more time. Here, this is the option is available here. If you want to do Arduino, I'm using for example Arduino Nano 3.0. Now I am not having this Arduino board. Just I am telling how to select, how to connect with hardware. Then code generation. There's device vendor also. You can type this Quadcopter vendor or Intel vendor. Based on that vendor, you can choose the device vendor type. For example, here automatically it chooses Arduino Nano 3.0 board. It chooses Atmel device vendor. It chooses AVR device type. In this manner, you can choose any type of board. Here, not available means you can get hardware support packages. It directly goes to MathWorks website. Here you can see lot of additional hardware support packages toolbox are available here. Just if you click hardware, click on new hardware, it goes to add-on explorer in MathWorks. Here a lot of options are available here. Here for example, Simulink hardware support packages for Arduino hardware I already installed here, so that it shows installed. If you want to install some more packages, for example another hardware, that is blue hardware and Vex microcontroller, nucleo boards, there are so many boards are available here. For example, I want to use for someone quadcopter drone project. It is the Simulink support packages for Parrot mini drones. If you have to design, similarly I already installed Raspberry Pi hardware, so that it's called it shows installed option. Here Simulink support packages for Parrot mini drones. Next you are going to see this example. If you have to interface with real time by using this MATLAB Simulink, also by using these virtual reality applications. Here what you have to do is click install only or download only. Install means directly install. It is a free only. Once you register with MATLAB, we can able to get all type of toolbox and block sets and user created toolbox, and also all the things we can get by using this option. Otherwise, one more option is available here in MATLAB main window. Here, click home page. Either this is a one more icon is there, add-on icon. Here you can get add-ons means directly it goes to MathWorks website. You can get the toolbox. What are the toolbox are not available in your version? You can get. Then click the hardware. When you want to connect different hardwares, means get hardware support packages means it automatically detect your hardware via your USB. It gives the corresponding hardware support packages with MathWorks. By using this, you can able to implement real-time implementation with this MATLAB Simulink. Also, you can generate HTML code. Also, you can implement, for example, if any other applications. If you want to implement in FPGA or ASIC devices, is also possible by using this Simulink. Here also model parameters are there, embedded coder software available here. Then so a lot of visualization options are available here. For example, Simulink data inspector, logical analyzer, analysis. There are so many options are available here. Can similarly, the another example after VR collisions. Then next one is the VR heat. That is a virtual reality well by using this heat transfer visualization with 2D animation. This example uses heat distribution data from VR heat example to create by index fact set mode. These are the files are you can able to record this one. There is a 2D AVI animation files. The software uses a MATLAB video writer object to record 2D animation exactly as it is appears in the viewer figure. Here you can download offline animation recording mechanism by setting VR world and VR figure object properties. There is a MATLAB having some inbuilt functions are there. By using this inbuilt function VR world function, you can able to control. Then VR figure object properties, you can be able to control the offline animation recording mechanism by setting this the type of property MATLAB functions. You can also use the Simulink 3D animation viewer also to record animation window. How to get the 3D animation viewer means you can get VR play animation. Now we are going to discuss about this VR heat example. How to heat distribution through a rod and something. Okay, now we check with. So for this example, VR heat example shows the heat transfer between this one. Here it's also 2D view. This one. Here, if you hit VR heat example, automatically you can view published version of this example VR heat.m file. That is where by using this MATLAB script here, textual programming. In the way of textual programming, you can be able to create some virtual reality applications. For example, this is where heat visualization, heat transfer visualization. This example illustrates the use of Simulink 3D animation with the MATLAB interface for manipulating these complex objects. Here, this is a step to load the that is a mat file. It's nothing but in the matrix form. Here, just we are after hitting run button, you will get this one directly. You can get by this textual programming way. Okay, this is the mat is nothing but in this example matrix type data is transferred between this were MATLAB and virtual reality. Well, this data is transferred between your MATLAB to virtual reality. Well, using this feature, we can achieve massive color changes here. Massive color changes or morphing also is it is useful. This is useful for visualizing various physical processes also there. For example, here I am now we can see here in this two-dimensional view also you can see within the time step you can see the heat transfer visualization by this example. Here one more example with animation, 2D animation. We are heat yeah this is your heat transfer visualization with 2D animation. Here also you can get the, after reading this one, you can get the published version of this example. We are heat anim.m. The previous one is created using this VRM 3D railway editor option. After reading this one, you can be able to get this in this form of MATLAB textual programming. Here, this is the program. Although it also with the 2D visualization option. This one, two-dimensional view. One more it takes up to time step is fixed with 4. Previous one is time step fixed with 2. Here in this way you can visualize your various type of physical process also there. Next you start with then how you play with play animation with Simulink 3D animation viewer. These are all the commands are instructions. You can type with the MATLAB command window. You will get how to play animation with the 3D Simulink 3D animation viewer. Previous one we are seeing with how to edit, how to play, how to create the virtual reality scenes. Here the next option, next interactive app is your Simulink 3D animation viewer. By using this, you can able to see the animation files. You can use also web browser. Also, you can use 3D animation viewer for one of these approaches. In this one, this at the MATLAB command window, just you type VRV option. You can able to see the virtual reality application files. Then already we discussed about the fresh user. You can able to install the viewer and editor by using this command in command window. Here I'll already discuss this one, how to create a new file, new virtual scenes, how to change the background, how to get the objects, how to get the textures, how to get the materials, how to get the nodes by using this one. The once you created the virtual scenes in this app, you can save it as .wrl file. By using this VR player, that is nothing but once you run the file, you will get by using this MATLAB VR sync. You have to call the VR sync by using VR sync. You have to call the WRL file, that is VRML file, where you can run the design, run your design. This is already shown what is virtual reality world driving Simulink models. This Simulink 3D animation provides apps for linking Simulink model and MATLAB algorithms to 3D objects, and it lets you visualize, verify dynamic system behavior and virtual reality environment, and objects are represented the virtual reality modeling language. Also, you can animate a 3D world by changing position, rotation, scale, and other objects properties during desktop or real-time simulations. Also, we can use the sensor signal. You can also inject virtual sensor signals from unmanned vehicle video cameras. Also, we can access 3D animation data in Simulink and on MATLAB post processing. Here, how to import CAD and robot models from other softwares like ANSYS and CAD software. We can use CAD models with 3D animation product. Here you can integrate the imported model with your virtual world. After you import the CAD model, use the Simulink 3D animation software to modify the resulting virtual worlds so that you can use it effectively. Also, you can export non-VRML model, that is your computer-aided design tools, including CATIA and robot visualization representation, that is your VRDF files to use with this Simulink 3D animation. You can also import model developed using CAD or 3D modeling into 3D simulation virtual world. You can import models from STL, FBX, and VRML files and CATIA software. You can import visual representation robots from URDF and STL, STF and Colada DAE files. These are supporting files. This one. How to link the MATLAB model? You are once you create with the virtual world scene. Afterwards, you can link with MATLAB model. Already we discussed with this example to help you to interact with the virtual world. The Simulink 3D animation product offers set of MATLAB functions. You have already seen the MATLAB function. What are the MATLAB functions to VR view option, that VR figure options? There are so many MATLAB inbuilt MATLAB functions are there, and these functions and construct using collectively as its MATLAB interface. Using customized GUIs to visualize static objects under relations with the virtual environment, such as interactive machine assembly instructions. Then visualizing 3D information based on independent quantity, and also using MATLAB interface functions in Simulink model callbacks, and a visualization system with massive object changes such as deformation and transformations. All things are possible with this virtual reality 3D world editor. Also, we can get the get the data from the dynamic models to virtual worlds, which is not possible using just Simulink signals. Also, next here one more important blocks in the Simulink 3D animation toolbox. So VR placeholder and VR signal expander blocks to simplify the model. To simplify the modeling, you can use the VR placeholder and VR expander blocks of the Simulink 3D animation library. Here, what is the use of this VR placeholder block? Sends out the special value that is interpreted as unspecified VR sync block, and then this VR signal expander block creates a vector of predefined length using some values from the input ports and filling the rest with placeholders and signal values. Then to control the position of a virtual object in one-dimensional dynamic model, and also this expander VR signal expander block with the control dimension as it is inputs for its three-dimensional property. The remaining vector elements are filled with placeholder signals. By using this block, also possible to when running the rotation also at the time of simulation also you can expand the signal VR signal expander block. You can possibilities is available. Then link to Simulink and Simscape multi-body models. These are now what is Simscape multi-body models means. Here previous versions, older versions are called Sim Mechanics, Sim Hydraulics, then Sim Power Systems. Then there are so many blocks, so many toolboxes are available. Now it combines with Simscape multi-body. In the Simscape multi-body having the Simscape hydraulics, Simscape robotics options. By using this Simscape multi-body, you can able to establish live data connection between model and the virtual world, create association with dynamic model object quantities corresponding with virtual world objective properties. By using particularly not only with Simulink 3D animation toolbox, also it along with Simscape multi-body models, you can able to link with Simulink. You can able to combine virtual reality editor to with Simscape multibody, so that you can able to create, for example, robotic based applications, some other applications, medical application, any other applications you can able to do. Also using this multibody, Simscape multibody and Simulink are common platform for modeling mechanical systems, and also you can able to visualization of model implementation in model lab. For example, create association with virtual world object properties such as positions and rotations. For example, we are moving. For example, I want to create one pick and place robot. By using this pick and place robot, I am to create in virtual 3D world editor. Here I want to control the arms and all things, pick and place hands and all things, you can able to control by via MATLAB Simulink option, that is called as VR sinks and source, VR expander, and VR signal blocks. So many blocks are available here, so that we can able to control this robot movement virtually. Is possible with SimScape multi-body toolbox. Use the SimScape Simulink 3D animation block library to connect a Simulink model to a virtual world. Here, the VR sync blocks allows you to write values from Simulink block ports to specified virtual world fields, and also to provide interactivity between virtual world viewer and a Simulink model. Use a VR source block or other blocks such as a space mouse input block. This is one more block is available in Simulink 3D animation toolbox. Here the one more example, robot arm with virtual reality simulation. This is you use this example shows the robot arms. This example shows the robot arm model in SimScape multi-body first generation and visualized using Simulink 3D animation. This example is available in MATLAB. Just you check with. This is a command to get the example. With this example, this is created by for example, in command window, just click Simulink, you will get the Simulink window. Select new model. Here it is a model window. You can select file new model, then go to the library browser, then drag and drop this type of robots. For example, if you click here, this is one subsystem. Inside this subsystem robot, here these are all the angles. Angles are what are the parts are available in SimScape multi-body. Just you can drag and drop and connect it. Just you can see after run what will happen is you see. Okay, this is our virtual animation. Also, you can plot the joint angles by using the scope. Okay. Just you see the graph is this one. Whenever you play the model, you see the view, set point view, default view this one. You can say set your viewpoint to bottom or right. These has to created by using this VRLM 2.0 software. This is only the animation viewer. Okay, now what is the specialty of this MATLAB Simulink is, once you create a design, whatever the movement, based on the movement, you can able to create the plot by using this one. Each and every angle you can able to plot this one. This is a 1, 2, 3, 4, 5, 6 angles are there. Six body sensors are used to create the joint angles graph. In this manner, you can see this is a robotic analysis. Then next example. Already we seen this one, and their vehicle dynamics visualization graphs is a combination of two virtual reality canvas with one figure and other graphical user interface. So here in this case, three graphs are displayed under the virtual scenes and updated in each major simulation steps. Here one more application with the airbag and crash test dummy with virtual reality simulation. Once this is a virtual reality application using MATLAB, especially for sellers of car in this car, in this type of car, having airbag and crash test application is there. By using this car, and this is a one way of selling the car manufacturers is by wearing field seat belt. What happened, for example, before simulation, before accident, or before any disturbance, before simulation is there. After simulation, after hitting, after car met accident, what is happened, what happened, you can check the airbag and this setup, belt setup is protect the driver in this option. In this manner you can interactively create the simulation by using this. In my car, the car manufacturers are shows this type of virtual reality scenes. By using this car, the driver gets safely whenever meet accident. In this manner, you can get the virtual reality video. For example, showing this one. Okay. This is the model, MATLAB model file. Okay. These are all VR sinks, and these are VR expander. Based on that, we have to make the design this one by using this Simulink 3D animation toolbox blocks. You can able to design this one. That is our application, virtual reality application. That is a crash airbag mechanism. This one. This is a passenger collision model. Just whenever I run this one, you can see before simulation and after simulation what will happen. This is a when met accident. This one airbag and passenger collision model. Here now you can see. Here it is an accident is happened. What happened? The driver is protected by using this passenger collision model example. In this way, you can design any type of application, virtual reality applications, especially for this one business application. Next one, the final one, the virtual reality application using MATLAB. For example, this is your Quadcopter project. I already we discussed about how to create the virtual reality application using this type of drones. These are Parrot mini drone objects. Already we discussed with how to get the hardware support packages for particular drone. By using this add-on option, go to home, get hardware support packages. In some separate window is available to get the particular hardware for this type of example created with Parrot mini drones. In this Parrot mini drone, these are quadcopter. This example shows how to Simulink model to model a toy quadcopter based on the Parrot R series mini drones. This is a real-time application with once you get this Parrot mini drone, you have to connect with MATLAB. For that you need hardware support packages for this particular type of Parrot mini drone series mini drone type. Then only you will get the interaction between your mini drone versus your MATLAB. Here this is the MathWorks Apple Hill campus group. Here this is an example shows the different point of camera. Here there are four cameras are fixed in quadcopter. Here in this type of mini drone camera, it analyzes the MathWorks Apple Hill campus at roof to estimate, for example, to estimate the snow levels of so on the MathWorks Apple Hill campus roof. Then to manage the model and source file, it uses the Simulink projects. It shows the quadcopter three-dimensional environment. It uses Simulink 3D animation. For the collaborative development of a flight simulation application, it provides an implementation of flight simulation application template. Another tool is here. This is the quadcopter free simulation model. It's created by using this Simulink 3D animation block and also with SimScap multibody and Sim events blocks. So by using this one, you can create quadcopter flight simulation model. Here, how to get this example from MATLAB? Just you hit the command ASB quadcopter start. It takes some more time. Meantime, just to see. Then one more tool is available here to start trajectory generation tool. To start this tool, once you open the project, run the project, you can set the trajectory generation by for the drone Parrot type of drone. This is the command to get this trajectory generation tool. This project is available in MATLAB. Just you can recall the example, then we are seeing the result. In meantime, any doubt, participants, please unmute yourself, ask any doubts and all. Otherwise, if you have any queries, just put in chat box. Just okay. Now we are seeing the quadcopter project simulation model. In this model, you can see the flight simulation model. Okay, thereby these are all the flight control system model and airframe model, and all the things are there. Here, this is a virtual reality scene. Also, you can able to control in real time also there by using this MATLAB. Here, there are visualization options are available here. Now you run. Take some more time. Then meantime we will discuss about one more application with virtual reality application with MATLAB. Here there are so many applications are there, especially for 5G antennas array simulation for millimeter wave wireless virtual reality headsets. Here this is developed by 60 gigahertz array antenna for millimeter wave 5G wearable applications. It's done by 2018 in the symposium on antennas and propagation. It takes some more time to see the output. Just is running. Here you can see the camera view, chase view, and this is your isometric rotation. Meantime, you can see the result. Just you can move. You can able to get the video information from the student. This is the movement of drone moving. In this manner, you can see. You can get the video signal from this drone. Yeah, now this is one. After running, so in this manner you can see the drone applications. If you want to implement in real time, you have to connect real time hardware by using hardware support packages. You can implement successfully in real time manner. Then the final one is the antenna array simulation for millimeter wave wireless virtual reality headsets. And then this example demonstrate antenna array for 5G 60 gigahertz application of wireless communication for wearable devices such as virtual reality headsets. Here, the antenna design is designed for this example is prepared by this Hong and Choi of Hanyang University. It's a IEEE paper, it is referred IEEE paper. The array is composed of four elements which have two patches and parasitic element. By using interactive antenna designer app and with MATLAB, you can able to design any type of antenna array. You can this type of antenna array patch antenna with two patches and parasitic elements. The parasitic elements producing a wider beam and one dimension to give a better coverage. The beams may be stayed with by varying the phase shift between elements to provide near hemispherical coverage. These are figure one shows the top view of the antenna array with substrate layer. These are shown red color and metal. This one and the metal feed lines and parasitic elements in green color. This one. Then patches are shown outlines. These are all created by MATLAB Antenna Designer and Sensor Array Designer app. You can able to create interactively. Then figure 2 shows the antenna array shows in the three-dimensional view. This is the same thing. You can use in three-dimensional view. The same thing you can create by using the virtual 3D well editor also, but not possible to design the real-time array. So that we are moving to one more software. There's a MATLAB antenna designer software. It is available in antenna toolbox. Then this is figure 2 shows the three-dimensional view of this designed antenna array. This is the plot of return loss of each antenna element of the array. The next one is the gain pattern broadside of the array with parasitic element and without parasitic element. Next one, this is a three-dimensional view of gain pattern. This is a three-dimensional gain pattern with 90-degree phase shift. And the next one, and this is a sweeping the phase shift between minus 90 degree to plus 90 degree with 30-degree increment. Then the important one is the virtual reality antenna array is mounted on a virtual reality headset. It is available in XCD, XF, DTD 7.3 software, as well as we can able to go for any other some other vendor. Here, particularly for this type of virtual reality headsets with this antenna array modeling is designed with XF DTD 7.3 version. Here, MATLAB, by using MATLAB, you can able to generate any type of antenna array. Then you can combine with this software. You can export your MATLAB model to this XF DTD 7.3 software. You can able to mount antenna array on a virtual reality headset. Then next one, due to the large size of beam array, the problem is there, and also the headset and head model used for actual animations. Then the computed gain pattern also there. This gain pattern shows the 60 gigahertz of headset and head model is used for actual simulation here. So that this is a simulation output computed gain pattern for this case. All element in phase is there shown in the strong gain of nearly 15 dBA. Then final one, this one after applying this 90-degree phase shift between elements versus elements, the beam is shifted about 30 degrees upside. Then both beams there are two beams are also with 0-degree phase shift and 90-degree phase shifts are shown in this image. Finally, the user can see the dissipated power on the surface head phantom from the radiating array is computed by the software and displayed. These are all developed for 5G antenna array simulation for millimeter wave wireless virtual reality headsets. Any doubt from participants? Sir, can you hear my voice, sir?